Hello there, programmers, and welcome back to our tutorial series on building a relational database with Go. I am Chris Franklin. Now, if you recall, if you've been following along in this tutorial series, you recall that last time we stopped with creating a SQL parser, bringing in a library for doing that for us, and parsing this into a pre-created struct for our queries. Okay, so what we're going to do today is we're going to start from there, and we're going to move to the next step of actually working with the database, which is actually executing the statements that come to us from the parsed query. Now, in order to do that, we actually have to create the basic structure for our database itself. And we're not going to be storing this to disk. We're not going to be persisting it anywhere. We're going to keep everything in memory for today's lesson. But this is the very foundation for actually creating a database itself. We're also going to simplify things a little bit. In a typical database, you would use something like a B tree for storing your database. We're just going to use a simple array of rows to be able to store all of our data for us, okay? So that's what we're going to do today. We're going to dig straight into this. Now, in order to do an actual execute on the statement, I'm going to need to create a new class or a new file inside of our core. So I'm going to go ahead and go up here to core and say new file, and this is going to be our row.go, okay? Inside a row, we're going to define our package, and we're inside the core package, and then I'm going to create the actual row that I need here. Now, we're going to hard code things right here, and the reason we're going to hard code is because creating a table from scratch and getting all of those data structures in place, that's a lot of tedious manual work, and it's not going to do us a lot of good to see how to set all of that up right now. What we're more interested in is what the actual data store under the hood actually looks like. So that's why I'm going to hard code things here, okay? So I'm going to go ahead and create the row struct, and then inside of this, I'm just going to give it a couple of fields here, and I'm going to as I said, I'm going to hard code these fields that we're actually using, okay? Yeah, so I'm going to create an ID, a username, and a password. All right, and I'm going to go ahead and save this. So now we have a row struct. The only other thing we really need to do inside of this file is we need to create a function. So we're going to create a row from query. Now the reason we're doing this is because I need to be able to convert the query that we're actually working with from inside of this library here. I'm going to take the query library and the query struct that gets generated from here. And I want to be able to turn that into this row struct that we're using above, okay? And in order to do that, we're going to create an empty row, and it's going to have all the default values in it, and then we're going to assign things into it, okay? To do that, all we have to do is we have to use a for loop here, and we're going to look at an index and field name of a range query over the q.fields. Now, you notice here q.fields is a slice of strings, so this is what we're going to use to actually grab all the field names that were being passed into our function, okay? Then what we can do is we can look inside of here and we can say if the f is equal to id, that means the field that we're setting is id, then we can set r.id, and we can set this equal to q.inserts. Now, I want you to notice that inserts is a two-dimensional string slice, okay? Now, it's not going to be important that we use the first dimension, really. We're going to set 0 by default here. We're always going to assume we're only setting the field once in a SQL query, although with this library, you could technically pass in multiple groups of values for the same field. But we're not going to worry about that. We're going to assume it's always the first one that you pass in. And then all we have to do is take I. So we're going to take out of the second array, the second slice, we're going to use the index of the field. So they line up, the field and the array and the insert value line up together there. So then I can copy this and I can say else, and I can do an if, and instead of ID, we're going to set username. And then here we're going to set r.id. Instead, we're going to say r.username. Okay? And finally, we can copy this again and say else, if, and then we're going to do the same thing for password. Okay? and then r dot password. Okay? Now, after we're done with all of that, all we have to do is return r, the row that we just created. Okay? So if we pass in the correct insert statement, and it has an ID, a username, and a password, we'll set those fields and we'll return the object back out. Otherwise, if these fields are not passed in, for now what we'll do is we'll just create an empty row, which will just have blank strings for ID, username, and password. Excuse me. Okay, so what else do we need to do? After we've created a row, what we're going to do is we're going to actually store the values. Now, in a table, in something like SQLite, what we want to store, the way we want to store this is in pages of data. They can also be called partitions, but we're going to call them pages because that's what they're called in SQLite. Okay. Now these partitions or page spaces are basically going to be a limited sized grouping of rows. That way it makes it so that if we know what page of data we're looking for, we can go to it very quickly, and then inside of that page we can very quickly look up the row that we need out of there without looking at every piece of data, every single row in the entire database. Okay? So let's go ahead and create a new core file, and we're going to call this page.go. Okay? And inside of here we're going to create our package core, and then I'm going to set up a couple of constants here. Now these constants are going to be page size, and a page size is an integer that is 1024. Okay, I just picked a number arbitrarily out of space, but basically what this means is this page size is, let's put a comment here, our maximum rows per page. Okay, that's what this is going to represent for us. We're going to store no more than 1024 rows in each page of memory. Okay. Then we want to say how many pages do we want to actually store. Again, I'm just arbitrarily picking numbers here. I'm going to say let's at a maximum store 100 pages, and we'll do this as an integer. Okay, and finally const max rows. This is going to equal to page size times max pages. Okay, this is just to give us a limit on the size of our database. We're not going to let it go forever. If you were creating something like SQLite, you'd probably want this to be a lot bigger. You'd probably want to do some testing on this. But for now, for our tutorial, this is what we need. Okay, I also need a couple of other things. I need a page result, and this is just going to be an integer. Okay, and I'm going to create an enum that represents either page success, which is a page result, and that's going to be IOTA. So this is how we define an enum inside of Go. And then I'm going to say page full. Okay, so either we have a successful insert into a page or the page is full. All right, that's what we're representing here. Then I need to create the page itself. A page is going to be a struct, and inside of it I'm going to create a field called rows, and it is going to be a slice of the row struct that we defined earlier. Okay, so this is what a page is. It's just an array of rows. Okay. Then I need a very quick convenience method. We could expose the size and of a particular page either as an integer value that got stored in the struct, or I can take the page itself and calculate my page size. What we're going to do here is we're going to return an int. Let's open this up, and then we'll just return the length of p.rows. Okay, so any particular page that we have, we can see how many rows are inside of that at any given time with this function. Okay, and then let's do func p page, and this, all we're going to do is create an add row. This way we can append new rows onto our page. So this is going to be a row struct, and we're going to return a page result. Okay. Oops. And this needs to be capital P to work. So first thing we're going to do is we're going to check the length of p.rows. Okay. We can either do it here at like this, or we can just do p dot page size is greater than or equal to the page size integer up top. If this is true, we want to return the page is full. We don't want to put any more data in it. It's full. Then p.rows is going to equal, we're going to use the append on p.rows, and we're going to pass in the row that we want to append to it. Then we return page success. Okay, so this is really simple. This is just a very simple implementation of this. We're going to append new rows that we create onto the end of the existing page. And then that way, whenever we look at the page size, we can make sure, is this thing not already full? If it's not, let's go ahead and add a new row onto the end. Okay, so again, not super complicated here, what this data structure actually looks like under the hood, okay? Finally, we're going to need to make a couple of additional changes. I need another new file. This is where we're going to actually represent our table. So we're going to put table.go, and we're going to create a core package that where we're going to create our table type, and this is another struct. And inside of this struct, we're going to put two things that we need. First, the total number of rows that we have inside of our database. Okay. Why are we doing it this way and not counting? Because if we had to count, we'd have to go through each page and count how many rows were in each page, sum them all up, and send them out. This way, we have a really easy accessor to saying, how many actual rows of data do we have? Very instantly be able to return it without having to do any iterations or any counting. Okay. Then we're going to have pages, and pages is going to be a slice of page structs. Okay. So save all of this, and now we have our new table. Then I'm going to create another enum. I'm going to call this the table result enum, and this is going to be an integer. And let's create our constant here, and we're going to say three things. One, the table is full, and this is going to be a table result. Oops, I hit the wrong button. Table result, and it's going to equal to IOTA. Okay. We can have two more things that we're going to return here. First, that the execute succeeded, so execute success, and second, that the execute failed. Okay. So if you remember, our engine calls execute statement on the core. This is where we're actually going to say, did we succeed in performing the action, or did we fail? Okay. And now let's go and create some actual methods on our table. So we're going to do tTable. We're going to do get table size, and I'm going to return this size, and I'm going to return a string here. Now, the reason I'm doing this is because I want to troubleshoot in just a few minutes. I want to be able to print things out. So what I'm going to do here is I'm going to create a convenience method for actually formatting and printing this out. So what I'm going to do is I'm going to return fmt dot sprintf, and inside of sprintf I'm going to say table size colon %d for the integer, and then I'm going to pass in t.numRows. Okay, so this is our convenience method. We create a table, and now we can easily print out how big is our table. All right, just want to make sure that we're actually adding rows whenever we think we're doing so. Then the last thing we need to do inside of our table is we need to create a new function, t*table, and we're going to execute an insert. So we're going to create an execute insert and an execute select and an execute delete and all of those eventually, but for just today, we're going to stick with the insert. This is so we can put new data into our table. This is going to be a query. There we go. All right. And we're going to return a table result. All right. And now for the actual fun. So if t.numRows is greater than or equal to maxRows, which we defined in the other file, then what we're going to do is we're going to return the table is full. All right, so we have a maximum number of rows we're going to allow to be stored, and if we pass that, we do not want to take any more data. It's way too big for us to handle. Now, we're going to create a row, and that row is going to come from row from query, the function we just defined just a minute ago, and we're going to pass in that query object. All right, and then we're going to find out which page number we need to insert this into. The way we find that out is we take t.numRows, and we divide that by our page size. And so if the number of rows is greater than 1024, that means we're going to move on to page 2, or page 3, or page 4, all the way up to page 100. Okay? And so now what we do is we say if page num t.numRows divided by page size, if the length of t.pages is less than or equal to the actual page number that we just calculated. So if we can see that the length of the pages, the actual length of this slice up here is less than the page number that we just calculated, we know that we haven't created a page yet. So here we're going to say t.pages equals append. Back to the array, we're going to append a blank page. So this is how we continue to grow our page slice. We're going to say if we are past the end of this thing, let's add another one. That way that we have a place to store our new row. Then we're going to say we're going to create a local variable called page, and we're going to dereference t.pages and the page number. Okay. So this is why we had to do this if statement here, because if you actually try to reference something that isn't actually in the array, if it's beyond the end, it'll have a panic in the kernel. The entire application will break, and we really don't want that. So this is our safety mechanism up above. So now we have our page. So if page.pageSize is less than the total page size that we can take. Oop, nope, I want page size. There we go, the integer page size. Then what we can do is we can say page.addRow, and we're going to add the row we just created. We're going to increment our number of rows by 1, and then we're going to return execute success. All right, if the page is already bigger than our page size, we've calculated it, and for some reason our page size, we're trying to put too many things in this, something has gone wrong. That means what we need to do here is return and execute failed. We can't add it because the page was undone. That means we're going to have to catch it up above and retry, and there's a lot of things that we can do here to actually create some utilities and some checks to make sure that everything is looking better here. But this is the basics of it. This is how we actually append data onto our rows, okay? Now there's a couple of other small things that we're going to have to change here to just make all of this work together. First, we're going to have to go into the execute.go that we have here, and we're going to have to change our execute statement to also take the table that we want to work on, okay? Now the way we do this is we just do table is a table, okay? So the table we're going to work on is that, and then inside, instead of doing info.message here, what we're going to do is we're going to say, I'm going to leave it there because I want to print something out in just a moment, and then what I'm going to do is I'm going to say core.execute insert, because we're on an insert, so we need to execute the insert, the thing we just created. And we're going to pass in the query and the table that we want, to work on, right? Oh, and this is Q, not query. Okay, there we go. So we're going to say core. There we go. Let's make sure we bring it in. Okay. And so we're bringing in our core. We're calling execute, insert on it, and we're passing in the query and the table. Now all of this should run through. All right, and then our print statement here, instead of this message that says this is where we should insert, what I'm going to do is I'm going to say t.get or table.get table size. This is the convenience method we created so that we can print this out and see what is our actual table size after we run this execute insert. Then, as you noticed, after we do this, engine.go turned red, And the reason is because we have execute statement being called with the query, but not with the table. Now, to do this, if you recall from the very first or second tutorial in this series, we set up a to-do here to set up the file for database. We still need to do this, but now what we can do is we can say t is : equal to, and we're going to create a pointer to core dot table. All right, and then down here, we're going to pass the table that we want to operate on. All right. And, oh, yeah, I guess I messed this up here. This needs to be an actual pointer if we're going to take all of this in and actually work with it, aren't we? So if we save that here, we've now got the actual table being passed into execute, and inside of the execute insert, we should take, yep, T star. Yep, okay. I think everything is going. Oh, no, here. Oops. I knew there was something that looked weird here. So, I'm sorry. This execute insert inside of our execute, this isn't quite right. Sorry. I need to come back here, and I need to say table.execute insert. There we go. That looks better. That looks like it should. Okay. So now all of these squigglies should be going away here. Okay. So now, let's make sure everything looks good now. And what did I do? I imported core inside of core. Uh-oh, what did I do? I created an import loop, didn't I? That would just be silly. Why would I do that? Okay, let's run it. Let's see what happens here. I'm curious. I think VS Code got confused. It did. It got confused. It didn't look like anything was wrong. Poor VS Code. It sometimes gets a little bit messed up. So what I'm going to do here is I'm going to do an insert into, and I'm going to say insert into, and then what I'm going to say is we're going to give it a table name. It doesn't matter. That's fake. And then I'm going to give it a field name. So I'm going to say ID, sorry. I need to fix the suggest here so that it knows where we are in the parser. And then we're going to pass it values. And the value I'm going to pass it is, let's say, 1. Sorry, 1. There we go. Let's do that. Let's make sure we put quotes around things that need quotes. And then we're going to go ahead and hit insert here and see what happens. Now look at that. Our table size is now 1. That's it. We now have successfully increased our table size by 1. If I copy this and paste it and hit enter again, we'll see table sizes 2. And that's the basics. That is a really bare bones, simple, in-memory database. We can now insert data into it. We can now create a second method, which we'll do in the next tutorial, to do a select on that table and grab everything that's inside of it and print it out to the command line here so that we can see what is inside of our table. So I hope you guys followed along. I hope you enjoyed this lesson. If you have any questions or you want to see anything more advanced on this topic, please leave a comment down below, and I would love to answer your comments and create more videos for you. So thank you all for watching. I look forward to seeing you in the next video.